Alright, today we're going to be looking at how to find the maximum of a function. So say we have some polynomial function like x cubed minus 6x squared plus 9x plus 5, and we wanted to find what are the maximum and minimum values of this function. We can do this using the derivative. What this means is that the derivative is going to tell us the slope of a graph at any point. So if we pick this point, for example, the slope at that point looks something a little bit like this. The trick to notice is that when we're at a maximum or a minimum, like right here, the slope is going to be equal to 0. So if we take our derivative and set it equal to 0, it's going to tell us all the points where our function is flat, or it's at a maximum or a minimum. So if we take the derivative of this using the power rule, we get this function here, 3x squared minus 12x plus 9. We can then factor a 3 out of this whole thing to get x squared minus 4x plus 3. If we continue to factor this, we get 3 times x minus 3 times x minus 1. So now this is our derivative, and when we set this equal to 0, we get 3 times x minus 3 times x minus 1 is equal to 0. We can quickly solve for our x's. We get x equals 3 and x equals 1. So these values of x tell us where our function is at a maximum or a minimum. So how do we know which is which? We can do this using the second derivative. So our first derivative is 3x squared minus 12x plus 9. If we take the derivative of this again using the power rule, we end up with the second derivative is equal to 6x minus 12. Plugging in the x values that we just found for our maximum and a minimum, we get 18 minus 12 is equal to positive 6, and second derivative at x equals 1 is equal to 6 minus 12, which is negative 6. Now what this means is that at x equals 3, we have a positive second derivative, which means it's concave towards the top. And at x equals 1, we have a negative second derivative, which means we're concave towards the bottom. And so it's pretty clear to see this means that at x equals 3, we have a minimum, and at x equals 1, we have a maximum, because this goes up, and then it goes down, and this one goes down, and then it goes up. So we have a minimum, min, at x equals 3, and we have a maximum at x equals 1. So now tying this all together, we can plug this back into our original function to find out what the y values are for this. So we had x cubed minus 6x squared plus 9x plus 5. Plugging 3 into this, we get 3 cubed is 27, minus 9 times 6 is 54, plus 9 times 3 is 27, plus 5. Adding these all together, we get that at f is 3, the function, or sorry, at x equals 3, the function is equal to 5. So we have a minimum at the point 3, 5. Now if we want to find our maximum, we can plug it into our original function. F of 1 is equal to 1 minus 6 plus 9 plus 5. So f of 1 is equal to 9. And so that means we have a maximum at the point 1, 9. So there we go. That's how you find the maximum and the minimum of a function.